everyone for joining us here today. This event was basically conceptualized, if I were to say, on a very short notice by us, when we saw that ICAD was providing the opportunity to participants who were coming to the COP to hold sessions in a virtual format with a focus on resilience and adaptation. And today is the day at the COP where the focus of most of the discussions are going to be around adaptation and building resilience. And therefore, we thought this would be a very apt, focus that we can give to the session, basically highlighting on the need for early warning systems. Of course, you need these systems at all the vulnerable spots, but it's also the fact that we are increasingly seeing how urban areas and cities are getting affected because of flood and heavy precipitation incidences. Therefore, we thought it would be good to have a session with a focus on the need for early warning systems in cities. And today we have an esteemed group of speakers from South Asia, covering different backgrounds of research related to disasters and solutions, basically that will be looked at with regard to addressing disasters. And we have about 4 speakers who would be taking about 10 to 12 minutes each, talking about the work that they've been doing in this space and how that has been helping, assisting people in decision-making at various levels. To begin with, I would introduce the 4 speakers who are part of the session, and then move on, one by one to each of the speakers to share their experiences with the group. We have with us Dr. Mandira Singh Shrestha, who's the program coordinator on the area of climate services and works with ICMOD in Nepal. We have Dr. Anil K. Gupta, who's a professor of policy planning and strategies and is the head of environment disaster management at the National Institute of Disaster Management, which is part of the Ministry of Home Affairs in the Government of India. We have with us Mr. Sanjay Vashisht, who's the director of the Climate Action Network in South Asia and has a wide range of experience in terms of working with organizations and as part of CANSA on issues that touch on disasters. And I would also be sharing a few slides related to the work that we did very lately on this subject, highlighting the various efforts being put by different organizations, including TERI. So to begin with, I would invite Dr. Mandira Shrestha to present her findings, and then we would move on to the next speaker. Welcome on board, Mandira.
A very good afternoon. Thank you very much, Suji, and a good morning to some of you there. I'm delighted to be part of this particular program, to be talking about flood early warning systems. And this particular presentation deals quite a bit with Nepal, though of course ICMOD, the organization that I am working for, is an intergovernmental organization that works in 8 countries. And for flood early warning, we've been working also in a number of countries, at least 6 countries in the region. So what I would like to now present today is, okay, let me just move my slide here. A little bit easier then. Okay, let me try to, are you all hearing my voice clearly?
Yeah, we can hear you. Yes, yes,
okay.
We can.
Okay, I am trying to move my slide here, but the slide is not moving. So I'll stop sharing and then share again here. Okay, so here we go. This time it should move. Okay, so what I would like to briefly talk about is the climate change and its impacts on floods, the different causes of floods, and the flood early warning work that we've been doing, particularly the end-to-end flood early warning. Describe a bit on in terms of what do we really want in terms of flood early warning systems, what do we understand, what are those components, and what are some of the efforts made for improving this in the region, and in particular in Nepal. I would also like to give you an example of, since here we are talking much more on urban floods, an example from Bhaktapur in Nepal, and then briefly a summary. So this particular slide is from our assessment, the Hindu-Kush Himalayan assessment that we launched in February of 2019. And what this particular slide is telling us is, giving us these scenarios, the 4.5 and 8.5 scenarios, and looking into the future and seeing that, and compared to the rest of the world, the region that is, the Himalayan region is going to be getting warmer much faster and much higher than other regions in the world. So this particular study is also showing that, our region is going to be 0.3 degrees higher in the Hindu-Kush Himalayan region compared to the world, and that and for some parts even higher. And so what would that mean for us as far as extremes are concerned? Well, when you're looking at the extremes, we see that the precipitation extremes will be on the rise, and then it's going to be more erratic. As we are seeing this year, there have been a number of events in Nepal as well as around the region where there has been erratic rainfall leading to a lot of disasters. And that this particular study also shows that there's going to be 8 to 12% increase in precipitation, and that the extremes are going to rise. Now, zooming into Nepal and looking at floods, here I would like to share with you some of the statistics. We see that, considering that it's a small country, we have quite a large number in the population, more than 5 million that have been affected over the last few decades, and more than 6,000 people killed. On average, we have about 170 people who are killed, and that in particularly, the 2017 floods stand out quite being one of the worst in the recent decade in terms of people being affected as well as being killed. So this is just some quick statistics. And then here I just wanted to raise this particular issue because it's important. We often tend to forget that women are affected differently from disasters, from particularly flood disasters. So there's a differential impact of flood disasters. And this is due to a number of reasons, particularly because of their mobility, as well as, having limited access to resources. So this is something that we need to keep in mind while we are developing flood early warning systems and working on disasters. And now the causes of floods in Nepal and in the region, of course, is both natural as well as anthropogenic. And particularly when you're talking about the natural causes, we're looking at high intensity, continuous rainfall over a longer period of time. We have also in higher altitudes, glacial lake outburst floods, and also landslide dam outburst floods. Now, as far as anthropogenic causes, of course, the soil degradation, the land degradation, the changes in agricultural practices are causing a significant rise in the riverbeds and the banks, and therefore causing more flooding. But also here, I think important to what we are discussing today is the main cause in terms of haphazard urbanization, the huge increase in population, that basically increasing the exposure and vulnerability to flood disasters in many parts of our region. And primarily in urban cities, we are seeing that these drainages are being clogged. There's a lot of congestion that is happening. There's very limited infiltration that is going into the ground. And of course, runoff is going to be high. So these are some of those causes that are there, which are not only in Nepal, but also, common to all in the region. The photos that you see here are some of the photos from this year's flood. Actually, we had a very untimely flood in October, early October, and a lot of devastation took place in Nepal, and particularly in Western Nepal. Now, here I wanted to draw your attention to the disaster in Melamchi. This occurred again in June of this year. And though the cause of the disaster was much high up what happened in the downstream. It brought a lot of silt and a lot of sludge downstream. And the photo here on your right side, you can see these houses. These are basic settlements that are there very close to the riverbanks. And this is one of also reasons where we are causing, seeing a lot of damage in terms of lives and livelihoods because of these riverbanks, and the land being encroached for settlements. Now, some quick pictures of urban floods, since we are talking about urban, and this was this year in and around surrounding Kathmandu Valley. So you can see, how stagnant water, basically water remains, and this is mainly caused due to high intensity, short duration rainfall, precipitation events, and how the whole, rivers that are not able to, withstand the flows are then causing a lot of water in the surrounding areas. So in order to reduce the risks and vulnerabilities, I just draw your attention to this particular framework. This is from IPCC, but has been adapted for this report that was launched in 2019, the Oceans and Cryosphere report. And here you see that the risk is a function of three elements: the hazard, vulnerability, and exposure. And I think it's very important to reduce risk. We need to address all these three different components. And in order to do this, one of the actions that is very important is, of course, coming up with a very robust early warning systems, and which is based on sound science and technology and partnerships, as well as a sound knowledge base. So with that, I just want to draw your attention to this particular end-to-end flood early warning system, which is the advancement in technology in terms of real-time data, through sensors, and then including, space-based technology, and then analysis, then getting that information down to the decision makers, and then alert, and then action on the ground. So this is this whole early warning system, end-to-end early warning system that we have. So according to the UNISDR, the early warning system, as all of us know, actually many here present at this particular event know, has 4 components. So we are not only looking at just the technical component in terms of monitoring and warning. That is why I showed the slide to you. Risk knowledge is extremely important, along with monitoring and early and warning services, dissemination and communication, and response capacities. So when we look at it a little bit closer, particularly these components, for a flood early warning system, when you say risk knowledge, it's mainly to do with, the elements of hazard, risk, and vulnerabilities. And then monitoring would be seeing how much rain is falling and what is the water level, how to make these decisions, flood forecasts, and then disseminating it various means and modes, and then getting the action on the ground. Now, one example that we have that we've been working in the region is the HKH high cost that we've been working with the World Meteorological Organization. We are looking at making information travel faster than flood waters. And here we've established a flood early warning system for the region. And one of the emphasis of this is really capacity building and training. So as part of this, we've been looking at various sensors to modernization of hydromet networks, transmission of data, and across the 4 countries where the instruments had been put in place. And now a big bulk projects have come in all these countries where real-time data is now being shared and also used for early warning systems using the latest technology. And this is an example from the Department of Hydrology and Meteorology from the government of Nepal. These green dots and blue dots that you see are the locations of the real-time monitoring stations, both for rainfall as well as for water level. So these are then providing real-time information, which is ingested into models, and then flood alerts are provided. So this is one of the products that ICIMOD has been working with the countries to develop. And this is for the entire Ganges-Brahmaputra basin based on a model, Mike 11. It's a mathematical model and looking at runoff as well as the hydrodynamic component. And this is for the whole Ganges-Brahmaputra. But again, it does zoom into certain areas like for Nepal, all these major basins from Narayani to Koshi to Karnali And as part of it, we also have the Koshi flood outlook, which then provides the information and takes the data both in situ as well as satellite-based information and provides the flood warning to the various stakeholders in terms of discharge. So the early warning process that we have in Nepal here is a simple kind of a diagram here where the Department of Hydrology and Meteorology is the mandated organization, and this alerts are provided through the National Emergency Operations Center as well as various other organizations and through multiple channels. So you're looking at flood bulletins, SMS, toll-free numbers, radios, TVs, also through Facebook and Twitter, and this is being disseminated. Example of this I just want to share here, where the Department of Hydrology and Meteorology is issuing the flood alert, and they're using various inputs to provide the flood alert, which includes, of course, the one that I just showed you, but in addition, many different products are being used by Department of Hydrology and Meteorology that is generated from different organizations and institutions, and it comes in both languages. So what does it take to make a good early warning system? Well, yes, sound technology is a must. Plus, we do need good governance and functional institutions where information is then shared down to the users, down to who needs it the most. So the last mile connectivity to the people are very much important. And so here you can see that we need to make sure that the communities are aware of the information of the early warning, they understand it, they accept it, and that they are ready to make the move, take action, and have behavior change. So this is an example in Bhaktapur. You can see how this whole road has been turned into a river, literally. And this was during the 2018 floods. This is just a case that I wanted to share with you. The population growth rate of the Bhaktapur city is basically at about 3%. And the land use, mainly it's the land use pattern that has changed over the years. So there's like most of the agriculture land that was there in place, like 60% of the agriculture land has been now converted into, haphazard settlements and urbanized areas. So basically not much planning has taken place there. And then you see that the river that is very close to these roads here, it has the width of the river has been reduced from 10 meters to 2 meters. So there's like 8 meters encroachment on either, 4 meters on either side. So making it very difficult. So as soon as huge intense rainfall that fell in 2018 August, the whole river basically in all the water and all the rain basically over the banks of the river, and then clogged these roads and cities. And plus drainage is a big issue. And this is just showing you what the change has been over the last 3 decades here. This is just a study that ICIMOD has done. Of course, we have the one for 22, but this just shows you the red points that the marks you see is the urbanized area, and you can see how drastically it has urbanized. So one of the issues is also the urbanized area increasing haphazardly and the reduction in the agriculture land. So in summary, there has been a lot of technological advancement. Yes, we have improved quite a bit in terms of early warning systems, particularly in riverine flood areas. Flash floods is still a challenge, but again, for urban floods, management that is still remains a challenge. And one of those links that is needed to be really robust is also the communication links in terms of getting the information down to the users. One of the points that I want to again highlight here is the need for resilient infrastructure for risk reduction. And when we say resilient infrastructure in the context of urban floods, then it's mainly drainage systems and proper solid waste management. All these comes into play when we talk about these. And then the institutional mechanisms and partnerships is central. So we need to also involve a lot of different stakeholders here, not only the decision makers, but also the private sector, scientific communities, and public sector as well as media plays a very critical role in terms of dissemination of this information. So in terms of then forward, looking forward in terms of flood resilience, what is it that we need to do? We need to look at integrating risk information to early warning systems. Yes, we have early warning systems, but to make it robust, we need to integrate risk information. And the institutional mechanisms need to be robust. The land use planning and zoning and implementation of policies and plans is essential. And also particularly in the case of urban areas, solid waste management is very much needs attention. Intense rainfall are predicted to happen more often in the future as the climate is changing rapidly. So the cities that earlier did have enough capacity need to upgrade their plans to adapt to such changes in the future. And so we need new planning is needed to accommodate these uncertainties of climate projections and also put in place resilient infrastructure. And finally, I think a forum like this, where regional collaboration can take place, sharing of learning, of experiences is necessary. And one of the areas is for urban floods, for increasing and enhancing the resilience of the people and the communities. So thank you very much for your patient listening. Thank you. Over to you, Suruchi.
Thank you so much, Mandira, for this excellent presentation. It shows the vast amount of work that ICIMOD has been doing in the area. And of course, it's very nice to hear about the work that you've been doing, covering not only Nepal, but possibly other parts of the region as well, and looking at upstream, downstream issues, highlighting that when we're talking about floods, it's not about just dealing with floods as a one-point solution. We have to address multiple areas, including drainage, infrastructure, development, and other aspects, and also highlighting the need for the last mile connectivity on communication channels. With that, we would move over to our next speaker, Mr. Anil Gupta, who is with the National Institute of Disaster Management, the head Environment, Climate and Disaster Risk Management. So over to you, and we look forward to hearing from you.
Thank you, Dr. Suruchi. I was listening to the previous speaker, Mandira. She provided an excellent composition of issues which are important for flood early warning system. And she also touched upon some issues of the urban flooding with real case studies. However, when we look at the flood early warning systems for urban areas or cities, I think there are certain lateral but very important dimensions which will be important and will make this early warning system for cities distinct from normal or the usual systems of flood early warning for the riverine flood or the rural areas. But at the outset, this is very important that now this climate change issue that is appearing as a we are calling as a climate change emergency, because these climatic actors which we have been emphasizing and which we recognize that are known to aggravate various hazards. For example, the heavy rainfall, heavy precipitation kind of thing, resulting into flooding. So there is a equal or sometimes more contribution of the non-climatic actors. So when we are planning for an early warning system, basically we also have to look at the impact-based forecasting system. So that is very important, because in cities the usual flood forecasting doesn't work, and the recent the experiments and recent pilots were for impact-based forecasting. And the second aspect that comes to my mind is very important. That is they looking at various layers of vulnerability, and that is socioeconomic vulnerability. Because the impact of the floods and impact of floods in cities to be seen that how much of population can be exposed, how it is going to affect the infrastructure system, how it is going to affect various sectors, and particularly the critical infrastructure kind of thing. And here we would also need to go deeper to finding to root causes of vulnerability. Second point is that when we are discussing about the early warning system or flood management system for cities, we should also understand the distinction or difference of cities within South Asia or the Asia Pacific as compared to the cities that we sometimes take example, for example, Paris and other cities of the European countries. The characteristics of our cities are very, very different in terms of infrastructure and also in terms of planning regime. And the third aspect in terms of social settings. So we cannot miss out these aspects. Just to name a few, the Indian cities, the floating population is a very important aspect. So, when we talk of vulnerability or when we talk that how many people can be exposed, if we do not take account of the floating population, probably our anticipation of the damages or anticipated of the social scenario, the flood scenario would be incomplete. Then migrant population, we have already seen in COVID pandemic also that the lack of information about the migrant population, because that information does not account for the census of the city as on date. So that is very important aspect. Then Indian cities which have blurred boundaries. So if we just go by administrative boundary of the city and develop a early warning system, I think that will be incomplete. So we also need to recognize the blurred boundary and the peri-urban areas, because these are the peri-urban areas which can play both the side. If their ecosystems and systems are intact, that can contribute to reducing the intensity of floods or the flood waters. But on the other hand, it can also contribute to aggravating the flood scenario. Now globally, now people are talking about that we need to move for urban planning from the conventional approach to landscape-based approach or the watershed-based approach. So any early warning system, when we are endeavoring to make a impact-based projections of the flood impacts, I think the land characteristics, including the landscape, it would need to be factored into this. Then if we take example of cities like Delhi and some other cities of India like Kolkata, so there are villages within cities. This characteristics is very different from what we call as cities normally at international level or when we sit at the global policy agenda. So how to deal with these kind of localities within city, because these are also the highly flood vulnerable locations, also low-lying areas also. So how to deal with that? Also industrial agglomerate. Many times we talk of the usual kind of infrastructure, but we miss out these kind of agglomerate also. The third point is that when we talk of the flood resilience in cities, I think we should also not miss out the co-benefits between adaptation and mitigation. Largely also we are missing out, and we have recently realized that the two streams were going very, very differently and silos, like adaptation, then mitigation, and third one is risk reduction, and then resilience. Though in the conferences and workshops we talk and we use these words interchangeably, but when it comes to actual working agenda, these things are dealt differently, and these have the opportunities of overlaps also, but synergies and co-benefits also. So how, for example, if we are having any kind of interventions of adaptation that can contribute to restoration and rejuvenation of wetlands within cities, how does it contribute to reduction of the flood intensity? And that should just 2 minutes, sir. So that would certainly contribute, and that has to be factored in, because the wetlands are also natural flood control sites. Then new land uses, again taking example of Delhi and other cities also, like urban agriculture, then institutional areas and city ecotourism. These kind of things are now emerging, and that is contributing both the side, to vulnerability side also and to resilience side also. So in the overall integrated flood management system for cities, how are we going to include this? Then the issues of data challenge, like migrant population is one, but there are several other aspects of data challenge that is very important in cities, because the usual models like Mike 11 are the other models which are used for riverine flood. A lot of factoring additional dimensions has to be done so that it can be applied in cities. Then the last point that comes to my mind is that we all agree and we all know that maybe in next few years only, maybe 3 to 7 years, we are going to see disruptive change in our cities. Our cities are transforming very fast towards e-city kind of thing. So any kind of early warning system or any kind of flood management system, if we do not account these kind of changes, for example, we are moving to economy and everything to be under automation. All the services of cities to be governed by automation. How are we going to deal with in that scenario? And also the social fragmentation kind of things. And the last point that comes to me, that the lateral dimensions of flood early warning and resilience in cities, 5 keywords like rights, the rights of the people, then resources, then revenue, and randomness. Randomness is how effectively we are ready to address the uncertainties, because the climate change means on more and more uncertainties of everything. We prepare for something, but it doesn't happen. Something else happens. That is important aspect. And then righteousness. So that is also that how do we bring a balance between the infrastructure growth and the natural systems protection within cities. So like the natural infrastructure kind of things. So these are a few points that I wanted to share at this forum for consideration. So thank you very much for inviting me to share some of my thoughts. Thank you.
Thank you so much, Dr. Gupta. I think some very relevant points made in your talk with regard to the importance of socioeconomics when we talk about cities, and how we have a very fragmented population coming from different backgrounds, the kind of locations, that we have within cities, critical infrastructure, which basically defines the root causes of vulnerabilities within cities, the need for looking at South Asia a bit differently compared to other cities of the world, given that our infrastructure is very different, the social settings are very different, and of course, our planning regimes are very different. Taking into account other issues related to the migrant population and floating population in cities, need for looking at different approaches for urban planning, and of course, looking at synergies and co-benefits when we talk about different terms that are in use with regard to climate risk or otherwise, challenges that need to be addressed related to looking at other development aspects within cities and their growth, and of course, looking at the whole issue with an integrated lens, so that we are on one side able to address the challenges of the city and development, but honestly solve the problems related to flood impacts. So with that, we move on to our next speaker, who is Mr. Sanjay Vashisht. He's the director of the Climate Action Network from South Asia. And as I said, he would be sharing his experiences of work in the related area, but also experiences of work with other organizations who've been touching on this subject, giving us a larger perspective of how things are being viewed related to floods and early warning systems. Over to you, Sanjay.
Thank you, Suruchi. I don't have any slides, so I'll use my notes to share some of the perspective from Climate Action Network South Asia. I just wanted to check if you all can hear me. I'm at a very noisy place at the venue, so just verify if you all can hear me.
Yes, I can hear you clearly.
Thanks, Suruchi. So greetings to Professor Gupta. Good to see you in the panel, and happy to share this panel with you. Well, from CAN South Asia's perspective, let me, first of all, about CANSA. CANSA is a network of civil societies. Globally, we are more than 1,300 organizations networked together to work on climate change in 130 countries now. And in South Asia, we are around 292 organizations in all 8 South Asian countries. And SARC is the basis of our demarcation of boundaries. And working on climate change, what we found, and there is an urban climate resilience program that we are working on, where our focus is on how to build resilience for poor. Because when we speak about urban areas, cities are basically for poor who are affected from frequent disasters in villages. Their livelihoods are getting compromised or being hit one after another, cyclone, floods. I think keeping that in mind, moving to cities is a way of adaptation. Suruchi, you also indicated towards migration. And if there's a climate-induced migration work that we are also working on, and our rough calculations, back of the calculations are that within South Asia, at the way our greenhouse gas emissions are going on, there will be 22 million people who will be migrating within South Asia, and almost 35 million by 2050, 22 by 2030, 35 million by 2040, 2050. If we would have polluted the way we have been polluting earlier, if we exclude NDCs that has been submitted, there would have been a population of around 44 million would have been migrating within South Asia. This is shocking. And where do they migrate? They migrate to cities, and they migrate in a very unplanned manner. But for them, it is a way of adaptation. It is a way of income generation. As someone puts it very rightly, that people do think about end of the world, and they do not want that. But before that, they think about end of a month. How do they survive by end of the month? And that's where income becomes an important issue. Salim, in a few months back, told us that we have already entered an era of loss and damage when IPCC Air 6 report was released. There is more losses of livelihoods. There is a limited capacity to cope. In fact, in majority of the population, there is no capacity to cope. And moving to cities remains the only option for them. And it is expected that from 2017 to 2014 in India, urban sector is going to go up from 34% to 41%. So 41% would be in urban areas. Now, in urban areas also, because of influx of migrants, there is shrinking space to manage disasters in cities. Chennai is one example. We know what happened few years back in Chennai, and we know what is happening now in Chennai. Again, flood and excess water cannot be handled. And one of the reasons we found is that within the urban ecosystem, the lakes has been encroached because of more need of space, and that means its capacity to absorb the shock of a disaster has reduced. And we can certainly attribute to development that has gone wrong, but I think we need to learn lessons from Uttarakhand floods, where houses were built on the riverbed, and how the lakes are being encroached in Chennai. Now, what needs to be done? I have 3 recommendations, and then I'll stop. Preparedness to flood influx need to be there, and preparedness in terms of the way we prepare ourselves in Bihar. Of course, Professor Gupta knows much better. In Bihar, every household in the flood-prone area has a boat, has a kit ready with IDs, medicines, and everything. So I think if cities are being impacted, we need to have that kind of preparedness. The response also needs to include community participation. They are the first one who respond. We have seen it in Kerala also. We have seen it in Chennai. We have seen it in Mumbai also. Communities, mobilized communities, and building capacity of communities to respond is important. And that would ensure the first response is effective and can minimize the loss of livelihood to start with. I'm not sure about loss of infrastructure. We cannot move infrastructure, but we can certainly relocate lives from the cities. Cities are, I think we also need to, remember one aspect. Cities are not about human settlements. Town planning should not be about how to construct roads, how many houses need to be built, where should the park will be so that people can go for morning jogging and all that. or where the commercial areas would be. No, I think it also needs to take in account where the green areas would be, where the lake, how the lakes will be preserved. It's an ecosystem that need to be protected. As long as we planned it as an ecosystem and also taking into account the new threat, which is frequent disasters and threats, I think uh, cities will remain a very vulnerable area to live in. So I'll stop here, Suruchi, all yours. Thank you.
Thank you so much, Sanjay, for those pertinent points. Basically highlighting the focus back on the urban poor and the vulnerable living in the cities and how they're affected. Of course, migration has been an issue with the numbers that we're talking about in the region that have been floating around. And of course, when you view it from their point of view, it is a strategy that is being adopted to cope with the stresses that communities face. Of course, you also touched on the topic of maldevelopment and how we've choked our natural drainage systems, which also cause floods and waterlogging conditions in various cases. The need for better preparedness, mobilizing the communities, and also a landscape-based approach in terms of point that was also actually touched upon by Mr. A.K. Gupta, Dr. A.K. Gupta, on using a different approach for urban planning, which is a landscape-based approach. And of course, there connects with the presentation that Mandira presented, which is related to, technologically speaking, what kind of systems are we talking about with regard to early warning systems that can be set up to provide information to people for better preparedness. So with that, I would just be, thank you so much. And I'm extremely sorry. I think we didn't know that the venue would be occupied. So Sanjay had to take it from somewhere outside at the venue, the session. But I think we really benefit from the points you shared.
I'm sitting in stairs.
And the stairs, yeah. So that's, thank you so much for accommodating that. And of course, we never felt that it would be the situation, but it's okay. That's adaptability for us. So yeah, so I move on to share slides of the work that Terry's been part of, working closely with the National Disaster Management Institute, where we've been, helping them develop a flood early warning system for the city of Guwahati. I'm just sharing my slides, just putting my slides up. I have a very few slides, actually. It's not that elaborate as we had, in case of Mandira presenting. I'm just trying to put it on. Yes. So, so this is a small piece of work compared to the work that we just heard, Mandira talk about, which is related to developing a flood early warning system for a certain city in India. And we were basically working very closely with the National Disaster Management Authority to help develop this particular early warning system and get it institutionalized within the city institutional framework. So just a little bit on the context setting, we do realize that year after year, the situation with regard to floods has been worsening in many parts of the world. There are need for better systems to be able to simulate floods and to be able to advise city administration on the impacts and the need for corrective measures. So different measures, and I think this is one point that Mandira also mentioned, while we're looking at technocratic measures, which are top-down, we are also basically looking at bottom-up approaches and methods that the other speakers have also highlighted. So I'm just giving an example of the top-down technocratic methods that need to be in place, basically to help people respond better in case of a flood. So of course, the need for flood early warning systems, which is currently operational in many countries. Of course, you have to contextualize it to the conditions of your own country when you're developing these systems. And historically speaking, the UN Office for Disaster Risk Reduction does recognize the importance and advocates the increased in the availability of such systems with the objective of meeting the targets of the Sendai framework for disaster risk reduction and the Sustainable Development Goals. The objective of having these early warning systems at the city level is largely with the plan to provide advisories to the city with regards to which the city can then plan a little in advance to the ensuing conditions that may emerge because of heavy precipitation and possibly a flood-like condition that is likely to emerge as a result of the rainfall that it is likely to experience. The different components of the flood early warning system, I'm not going to get into the details of it. Of course, it takes into account the weather of a particular location, does the analysis, some bit of modeling and analysis, links it to the study domain, and then starts projecting in terms of the runoff that is generated. And if we are basically likely to observe some high peaks, which may translate into the form of floods. And of course, the last bit of it is once such information is basically generated, in what form and format do you basically share this information to the users? And whether it's web-based information or you're using other formats to reach the information right up to the ground level so that people are better organized. This is basically the city of Guwahati, which is located in the banks of the Brahmaputra River, very frequently flooded year after year. So of course, we do experience many flood events in the location that I'm talking about. And a little bit of rainfall also that the city receives actually makes the city flooded. Of course, it's not just a problem of the weather. There are also possibly issues of the way the location of the city and the way the city is structured. Therefore, the need for a flood early warning system that basically was felt by the National Disaster Management Authority, and the need to institutionalize it within the city planning processes. There are several reasons, as I said. Of course, rainfall and excess. It is a region with a high amount of rainfall. There are lowland areas, that are there which easily get flooded with a little amount of rainfall. There are issues of maldevelopment, choking of drains, links to the waste management system and its disposal, issues of landslides and siltation, which also choke the drains and therefore make them ineffective in terms of taking the stormwater or absorbing the stormwater of the city. So there are multiple challenges, both coming from the weather side, but also from the development side that we observe. And therefore, the work which was basically related to development of this early warning system. This is the location we're talking about in the study area. The different blocks that basically being covered. As Mandira pointed out, the data from this and a lot of data handling that happens when you're basically developing such kind of system. The broad architecture that we are also using for the flood forecasting here and the early warning system is to use the IMD forecast data, which is provided at an hourly accumulated rainfall time step. So every 3 hours, and which is basically then fed into a weather forecaster to be able to give us the forecast for a few number of days ahead, which is then basically analyzed further to be able to produce it into an information which can be used by the user at their end to see if the conditions are getting created for a flood-like situation or waterlogging situation in the city. And of course, transferring that information in various formats to the user. And you can see below that there are different kind of warning signals in terms of a high risk, moderate risk, and a low risk that is basically transferred. So this is a system that was basically developed for one of the cities that we're working on, and currently we are in process to develop another city of India. And of course, there's a web portal where the information is live and constantly updated for the State Disaster Management Authority and institutions at the state level to take cognizance of, to transmit the warnings to the users. There are line graphs which basically help us to identify the peak periods and issue the warnings. This was basically launched in 2020 with the government of India for the city of Guwahati, and of course the plan is to see if we could replicate the model for other cities of India, and we are already working with the government in terms of developing it for another city. So this is a collaborative effort, very long with many other organizations, including the government of India, has been trying to see if we can set up these systems. Of course, with the challenges of development and contextualization to the regions where you're developing these particular systems for effective early warning systems. With that, I would just close the discussion, and I would like to invite the audience, if they have any questions for the esteemed speakers, to either speak up or indicate that in the chat box, by way of which we could basically respond to your queries. So can we have a raise of hands and any questions from the audience?
Suruchi?
Yes.
If I may. There is a question in the chat by Fahad Haider. He asks, how accurate is the rainfall forecast data? And in general, these flood early warning systems. So he is inquiring about the accuracy of the rainfall forecasts and the early warning systems that are being generated and provided. So if I may respond to that, is that okay?
Yes, Mandira, please.
Okay. Fahad, there are a number of rainfall forecast products that are now currently available. We see that the rainfall forecast products that are being generated now is certainly much accurate than what it used to be several years ago. You get it at a finer resolution, also 4-kilometer resolution, and the accuracy is also quite promising. So, and using those rainfall forecasts, particularly when you are doing your modeling for flood forecast, we are using, various types of rainfall forecast products, and some of them are the WCRP, WRF rainfall products that we are using, also the GFS rainfall products. There are several products that are available, and we see that the flood early warning that is being generated, it very much depends, of course, definitely on the scale that you're looking at, but the ones that are being generated are pretty accurate, pretty promising also in terms of the timeliness of the flood peaks, as well as the volume or rather the magnitude of the floods. So the example that I showed in my presentation, the flood outlook that we are generating shows quite promising results. Yeah, and this becomes even more promising when you're looking at more at the community level. That is even more accurate, but with very short lead time though. Yeah, thank you.
Yeah, I think I fully agree with what you said. With time, have technologies changed and the advancement in science and understanding, where uncertainties have been reduced over time. Our next question, if Sanjay, you're there, is I think one of the participants, Eddie, basically asking how far ahead do you want the communities, and what is the chances of false alarms, and have you calculated that?
Hi, Suruchi. I think, yes, false alarm could be there. But I think someone who decides to migrate from one place to another, they do not migrate on false alarm. It's also always after, compromising their coping capacity, and then it's difficult to survive for them, they have to migrate. That's one. Then in terms of false alarm, I think be prepared for the all kind of alarms. I think nowadays threat is real, impact is visible. I have not seen in last few years any false alarm. At least the weather predictions are very accurate, and we know how how. In fact, I should also share this. One of the findings in the Kerala flood was that last year, last year, I think 2019 or 18. It was taken as a false alarm. Nobody predicted that going to be rained so heavily, and we know what were the consequences. In fact, they say the coping, if they would have taken that warning seriously, the coping response could have been that drain the dams little bit so that the excessive rainfall, sorry about the noise, excessive rainfalls can fill them up, and there would not have been a flooding situation. So any alarm, we have to take it seriously. We saw what happened when one alarm was not taken seriously.
Yeah, I agree. And with time, as Sanjay just put, I think the certainty of the information has been increasing in different parts of the world. Just an example from India, we have in today's date and time easily about 25 Doppler weather radars that are operational, and India plans to, in the next 2 years, install 20 more in the hill locations of the eastern and western Himalayas. So ideally, I'm assuming different countries are on the go in terms of building resilient infrastructure, installing resilient infrastructure that may help communities and institutions in their decision-making processes related to disasters, and especially with regard to floods. With that, I think we're just left with a minute, and I would just wait to see if there's any last burning question that anybody has for for the speakers.
Is it possible to take a group photo real quick if everybody is for it?
Yes, we should. So Neha, if I can, sorry about that. Sorry, Neha, if we can just have the group photo taken. So if I can request everybody to have their photos, their cameras on, so that we can take the photo.
Yeah, if the speakers can like turn their videos on.
Okay.
Yeah.
Okay. So do we have everyone, and can we have the photo taken? Yes.
Would request the participants to turn off the videos.
It's okay. I think we'll just take the photo.
Okay, sure.
I see that there is a question on by Atik Molik regarding if there is any study incorporating solid waste management. Yes, in fact, there has been a study, taking 2 cities, one in Nepal in Bharatpur, and the other one in Bangladesh, regarding urban floods and solid waste management. And there is an article that is available, actually, that has been published, which I will be happy to share the link with, but maybe I'll give it to you, Suruchi, and if you can later share it with the participants, if that's okay.
Sure. Neha, have we taken the photo?
Yeah.
Okay. Thank you so much. I would like to thank all the speakers who joined us today, despite their busy schedules, and share with us their experiences and work that they're doing in related areas. And I also thank the participants for having joined us here today and the interesting questions that they have asked us. In fact, frankly speaking, Sanjay, I never heard the term false alarms until today. And so it's a learning for me also as I'm interacting with the team and the group. So once again, thank you all. And I hope there are opportunities where we all connect and meet again in the near future. Thank you very much. Goodbye.